I'm going to plug in at the end. So, yeah, I'm going to multiply radius of Neptune cubed and radius of Neptune cubed here. And then I'll take the square root, right? Okay, so I get TA squared equals TB squared over R sub B cubed times R sub A cubed. What's nice about this is the period of the Earth is 1 year. The radius of the Earth is 1 astronomical unit. So this is 1 over 1. Yeah, it's very handy, right? Yeah, I need to take the square root of that. An astronomical unit is defined as the distance between the center of the Earth and the center of the Sun. Or the average distance. Because, as we know, Kepler's first law, we move in an ellipse, so that radius, orbital radius changes. Alright, anyway, so we've got the square root of 1 year squared over 1 AU cubed times 30 AU cubed. Okay. Or the square root of 30 cubed. These AUs cancel out with these AUs and we're going to be left with years. It ends up being about 164 years.
We're in like half Earth is walking off there, somebody just like eliminate this step of like very like that commission notice the square root.
Yeah, if you can memorize that, more power to you. What I would try to memorize, because it's not on your formula sheet, is the ratio, period squared to radius cubed, because that'll come in handy.
So how long would it take?
It would take 164 years.
Does it actually?
In real life?
Yeah,
or?
it really does. So the further you get out, the bigger and bigger the orbital periods are. It takes Pluto, I think, 212 years to get around the Sun.
Didn't it just like recently finish like one whole revolution?
Well, if you're saying recently,
Like,
if you come back to it.
No, yeah, I thought I read somewhere that like Pluto finally made its first like tour.
Yeah, the first complete trip in 200 or so years.
Yeah.
Pretty crazy. All right.
It's like what all the plotting.
So a year on Pluto is, over 2 centuries here on Earth. Here we go. Today, you guys, period 5, you're going to be able to experimentally determine tangential speed and period. You're going to do that through a flying in circles lab this period. I'm sorry we're not going to have any formal lab report, but we're going to work together and think about how to find those things without using a stopwatch. And then we're going to talk about gravitation again. Because the test is coming up next week. I want to make sure we get some practice in.
Oh yeah. That's next week.
Okay. Yeah, oh yeah, that.
No pressure.
What day next week?
Tuesday and Wednesday.
Okay, you said Tuesday? On Tuesday?
Yeah, on Tuesday you'll get your multiple choice part. Because that's the shorter part. And then on Wednesday, we'll do the open-ended, recognizing that sometime I got to spill into your study hall.
If we come like a bit late to the class, we have like 2 extra minutes at the end.
You want me to report? No, I understand. If you're let out late, that's fine. Okay, so here we got,
It takes a while to get here.
we have flying pigs. Okay, in order to operate your flying pig, you need to turn them on. And then kind of give him a shove in the right direction, like kind of approximate his path. Whoa.
I thought you. I'm going to hit my knees.
So, eventually, after about 10 seconds, if he has not gotten a nice, uniform circle going, then start him over again. Okay? And if somebody can keep them still over here so that this isn't pulling back and forth. That's even better. Unfortunately, I only have 2 flying pigs, but I do have other craft. By the way, to stop them, you're going to want to just kind of pull up on the string and then turn them off. I'm sorry, it's very sad.
What does he do if you just set him on the ground?
Does he keep constant?
He just does that. He doesn't have enough lift.
I know, but it would make me so happy if you could.
We also have...
Not nearly as cool.
What is nice is we have 5 set up, and we can kind of just move the chairs around so that we can make room for our flying devices. This little thing pivots in here. I'm sorry, I couldn't get the real flying pigs. These planes go a lot faster, so you got to make sure that you're as far away from the barriers as possible. But it's the same idea. You turn them on, and you try to give them a tangential velocity or guess at what it might be. And you wait a while until it kind of stabilizes. This one goes a lot faster than the other. There's another type of plane that's the same idea. Okay?
Do they keep constant?
They keep pretty darn constant, yeah. Wow. So, again, just like I borrowed them from Dr. Waldeck, and she bought them with her own money. Please just be very careful with these. And again, this one looks a lot dangerous, more dangerous to stop, but you can kind of just come in there, grab the and turn it off. Okay. So here's the thing. You're tasked with finding the time, the period of revolution, and you're tasked with finding the speed. The other thing is you don't have stopwatches. You're not allowed to use stopwatches. Yeah. So what I'm going to suggest, if you got the paper on the way in as you were supposed to, the first thing you want to do is start with a free body diagram.
Trying to pass whatever they want.
I really had to remember that. Okay. I'm gonna do that.
Stop it! Stop it! No! Sam, don't do it. Stop! It's your wife. Is your mama proud of you? Just say
You need 2 more down there.
She gave up. Thank you.
Start doing your analysis and try to figure out how you're going to determine the speed without a stopwatch.
Not the app,
No, right?
They were in first to go. Me and you.
Who's the first one to say something?
Well, there you go.